All right. Quadratic formula. Here's the cool thing, guys. The quadratic formula is set up to be used with any quadratic and solving any quadratic. As a matter of fact, I have students who have programmed the quadratic formula into their calculator. So graphing calculator, you just enter in the A, B, and the C, and it calculates it for you. It defines the solution. Remember what we're doing here. We're trying to find where, if you look at this picture down here, where the parabola crosses the x-axis. And the quadratic formula will do that for us on any quadratic. Okay. The quadratic formula, I'm not going to go through the proof of it at this stage. That'll be done. I'm going to save that for another time. But it comes from completing the square in general with the quadratic equation ax squared plus bx plus c. And if you complete the square with the general standard form of a quadratic, ax squared plus bx plus c equals 0, you end up with the following formula. X equals negative b. This is the plus or minus symbol. Okay, that's how you get the two solutions at times. Square root of b squared minus 4ac all over 2a. You'll have to memorize this formula. Have any of you guys heard the song of the formula? It goes to the tune of Pop Goes the Weasel. We love formulas. And maybe you'll make your own. As lullabies, here's a new lullaby for you. Ready? And then you're going to sing with me. It goes like this. See, this is going to ingrain it in your head. It's x equals negative b plus or minus the square root b squared minus 4ac all over 2a. That's it.
It doesn't help because then you have to memorize the words.
X equals negative b plus or that's not that hard. Plus or minus the square root b squared minus 4ac all over 2a. So all kinds of different tunes of that song. You guys are going to have to memorize this formula. It's going to keep showing up. Okay. It'll keep showing up all the way through the rest of your math career. It's like a Pythagorean theorem. It just keeps showing up, right? Mitch? Quadratic formula just keeps showing up.
That's called sarcasm.
Oh, he's not here.
He just like turned sideways like shook.
Can I what? No.
Oh.
So here's all you have to know to use this formula. A equals 4. B equals negative 6 and C equals 7, and if you can identify A, B, and C, you just plug them in. You just plug them into the formula. So you can see why it's really easy to program even into a handheld calculator this formula. It's not hard. It's really not hard to do. Now, as you're going through the song in your head, memorizing that formula, we're going to use the formula in just a little bit. We're going to do just a couple examples of this, and then you're going to try a few on your own today before you leave, and then you'll have some homework on it. Now there's a special part of this formula called the discriminant, and this goes full circle back to section 2 of chapter 9. We talked about the 3 different cases here. You could have the case where we have we have 2 solutions here in green. We have no solutions there in red. And then in blue here we have 1 solution. Those are the 3 possibilities for solutions for quadratics. And the discriminant, which is the part of the quadratic formula underneath the radical here, can be used to determine the number of real solutions. Okay, the discriminant is the b squared minus 4ac part of that formula. And so rather than drawing the graph, you can tell if a quadratic equation has no real solutions by just plugging in a, b, and c to that part of the quadratic formula. In other words, if you plug in this a, this b, this c here, and you get a positive number, there are 2 real solutions. So if you plug it into that b squared minus 4ac, it's called the discriminant, you will have 2 real solutions. if you plug it in to the formula and you get a negative number, that means you have no real solutions. It means the parabola never crosses the x-axis. And if you were to plug in A, B, and C to that formula and get 0, you would have one real solution. Let's try it with this sample one up here. You think this has 2 no or 1 real solution? Let's see. If we plug in b squared, so we'd have negative 6 squared minus 4. A is 4 and C is 7. Is this number right here that I just wrote in the little box here going to be positive, negative, or 0? Negative 6 squared is 36, right? And I'm going to subtract, is it a number bigger than 36 or less than 36 or equal to 36? 4 times 4 is 16. 16 times 7 is bigger than 36, right? So this number is going to be negative, meaning this guy right here would fall into the no real solutions category. Okay. So here's how we use the formula to find the real solutions when they do exist. First thing we do is identify A. What's A in this case? It is 1, yes. There's an unwritten 1 there. And then B is negative 2 and C is negative 8. So we identify those 3. And then we plug it into the formula. We're just going to do this top left one and the bottom right one. So if you run out of room, just write over. Just keep going down. Okay? You might run out of room. So it's x equals what? Negative b. So if b is negative 2 here, it will become positive 2 in the formula. Plus or minus the square root b squared. What is b squared? 4. Yeah, we can take the negative 2 and square. I'm going to write it down here, but in the future I would just do the squaring in your head like you guys did. So negative 2 squared minus 4 times A is 1 and C is negative 8 all over 2 times 1. If you want, you can just scribble out the now you try underneath this. So just keep working down. We're not going to do that one. We're going to do this one in the right-hand corner. So we have 2. Oops, it doesn't want to let me write now. So I'm writing over the top of whatever that was. All right, so 2 plus or minus, and then we have to figure out what negative 2 squared minus 4 times 1 times negative 8 is. You can do it in your head. It's not hard. You can also do it on a calculator. I'll show you both. But negative 2 squared is 4. And then I have 4 times 1 is 4. 4 times negative 8 is negative 32, right? And so I have 4 minus a negative 32. You got to really watch your signs on this. This first number, the b squared, I don't care if b is positive or negative, this will always be a positive number here. Okay? It will always be positive. But 4 minus a negative 32, let's write it down just so you can see it, becomes 36. So it's x equals 2 plus or minus square root of 36 over 2. And if you want to, it can all be done on the calculator. You can do all this on the calculator, but it would look like this. You'd have in parentheses negative 2 squared minus 4 times 1 times, was it negative 8? Yeah. And And you hit enter, and there's a 36. So you can enter it into the calculator just as we wrote it down. Every time you put in a number for a letter, put it in parentheses, and it'll figure it out for you. So there it is. And square root of 36 is 6. So we have two different answers here. Two different answers. We have x equals 2 plus 6 over 2, or x equals 2 minus 6 over 2. What? Okay. Did you see how I got the 36 here? Right?
Yeah.
That's all the stuff under the radical, just doing the arithmetic. And the square root of 36 happens to be a whole number. It's 6. If it weren't, we would stop right here. I'll show you what that looks like. We would stop right here. It's just like they're completing the square if it's not a perfect square. It's actually more work if it is. And then 2 plus 6 is 8. 8 over 2 is 4, so there's one solution. 2 minus 6 is negative 4. Negative 4 over 2 is negative 2. There's the other solution. So we could have factored it in the beginning. When I get two rational solutions, that means we could have factored it.
If you sing everything you do, that's a problem.
Sing everything I do? No. Well, thanks for asking. You like my singing? I'm like, oh, that's great. Thanks. All right. We could actually do. Let me just check my. We could do either one of these. I'll pick one of them to do. So we have enough room.
It's already open.
Yeah, let's actually do this top one rather than the bottom right. I'll move this out of the way. You can just scribble it out. Here we go. So first step, just like with completing the square.
Wait, are we doing
Or
the
not
top or
with
bottom?
not with complete. We're gonna do the top, I think.
Okay, yeah.
We'll have more room. So 2x squared minus 3x. This is actually this. I take that back. It's the first step is the same as it would be for your skill when you're factoring. You're going to subtract the 1 over. If you don't put it in standard form, ax squared plus bx plus c, you will not get the right sign with a, b, and c to plug in. So in this case, a equals b equals negative 3 and c equals negative 1. You don't need to write down what a, b, and c are. You can just go straight to plugging them in. So x equals negative b. So in this case, what am I plugging in? It will just be 3 plus or minus the square root. I'm kind of trying to sing it. B squared. What's b squared going to be in this case? 9. Negative 3 squared is 9. Minus 4 times a is 2 and c is negative 1 all over 2 times 2. So we can do this one in 2 steps. There's the plug-in step, and then there's the arithmetic step, and then you're done. Okay? So we've got 3 plus or minus 9 minus 4 times 2 times negative 1. See how there's a minus and then another negative in here? That's going to change it to positive. 4 times 2 is 8. 8 times negative 1 is negative 8. 9 minus negative 8 is 17. And in terms of this skill, you're done. You've solved it. It's an exact, simplified, radical form in this case. So you're done. Okay. Now, if you're doing a real-life sort of problem, you're asked to find decimal approximations for this. Here's what it would look like on your calculator. You go to your calculator, and here's what you need to do on your calculator. If you're going to plug both the top and the bottom in all at once, you need to put parentheses around the entire top portion. And you cannot do plus or minus all in the same step. You got to do one and then the other. So pick one to do. It looks like this. Left parenthesis, you go 3 plus second square root 17. It's going to put a parenthesis in there. You got to finish it and then put another parenthesis. If you do not put parentheses around the entire top portion of that fraction, if you do not put parentheses, you might want to write this down how you would type it in. It will not do the order of operations correctly. And then divided by 4. We have 4 on the bottom there. So that's what it looks like. In parentheses, 3 plus square root of 17 divided by 4, and we get one of our solutions. It's 1.78. So if you're asked to do a real life sort of problem, otherwise just leave it in radical form for now. And we haven't even talked about simplified radical form yet. That's coming next chapter. We'll relate that. Okay. The other one, you just retype it, or you can hit second enter. And it will recall the previous line. So guys, is that clear on how to do this on your calculator? You've got to use parentheses here to make sure that it does the order of operations correctly. It's got to take the whole top portion and then divide it by the bottom. And if you don't put parentheses around the entire top, it will not do it correctly. So you're welcome to do that. The answers on the book homework that we do on Monday, listen carefully. The book on Monday, guys. On Monday, the book answer stuff, like they will write it in decimal form. They'll ask you to round it in there. On tonight's homework, what you're going to be doing for me, I'm going to ask you just to leave it and simplify it. Just in radical form, not even simplify it. That's right. All right. Some more examples here. We're going to skip over these to the discriminant stuff here. Just want to say a little bit more about the discriminant. So skip over to the discriminant stuff. We're not going to do all of them. Okay, we're just doing selected ones. So each of these represent either 2 solutions, 1 solution, or no real solution. Here's how you check, guys. We take b squared minus 4ac. Okay, you're just going to do the b squared minus 4ac part. All I want you to do on these is be able to tell me how many solutions it has, not find them. So here we'd have negative 6 squared minus 4 times, what's a? 1 and 9. And so I've got 36 minus 36 equals 0. You remember what the interpretation, you might have to go back. Yes. If it equals 0, how many solutions does it have?
No, I actually have a question.
Yes.
What happened to the over 2?
Okay, we're not doing that right now. What we're doing is just checking to see how many real solutions we have based on the discriminant. We're not solving it completely. Now we're just checking the b squared minus 4ac part to see how many solutions we have. We did this back in section 2 with the graphs. The graph either crossed twice, touched once, or didn't cross at all. We're doing the equivalent of that with the discriminant. So if I get equal to 0, what it says in your notes is that means there's 1 solution. Yeah. This next one, it would be 5 squared minus 4 times negative 3 times negative 7. That's 25 minus 12 times 7 is 84, and that is a negative number. Okay, that is a negative number. It's negative 59. So the fact that that's negative means there are no real, it's messing up here, solutions. Okay, so no real solutions. And the final one, we have, first we have to set this equal to 0. And so we've got 2 squared minus 4 times 7 times negative 8. This board's giving me trouble right now. 4, this is 28 times 8, which ends up being, when you add it all together, this is 112. Because, okay, ladies, because of the 2 negatives here, That's going to change this to a positive 112. So we end up with 116, which means 2 real solutions. So when I give you bookwork on Monday, homework on that, they're going to ask you to just tell how many solutions based on the discriminant. What's nice about the discriminant is you don't have to go through, on this one, you don't have to go through the entire solving process to realize there's no real solution. Like if you get a negative under the square root, just stop and say there are no real solutions, and you got to come back and browse for 2 to find out what the complex solutions look like. But that's it. Okay. So here's what I'm going to have you guys do for homework, just so you know. We're spending 2 days on the quadratic formula. Okay, we're going to do the textbook homework on Monday. I'm going to do a little bit more, just a little bit more instruction on Monday, one more example or 2 more. But what I want you to do today, instead of the classwork that's in here, which has almost no room to write on here, I created a worksheet here that reviews everything we've done up to and including the quadratic formula. And I'd like you to do this. I think this will be a really good review. And the idea behind this, to show you this last page, turn to the last page of notes there. Last page of notes, is that as you're putting all this together, and we start thinking about, the test on this is, I'm going to give you a quadratic and ask you to solve it. And you're going to end up choosing a method in some cases. And the methods we have are, you could graph it, I guess. I mean, that's the rudimentary way of doing it, right? Graph it. You could maybe, if it doesn't have a middle term, if it doesn't have a b term in it, you could take the square root of each side, solve it that way. We learned how to solve by factoring, completing the square, and then the quadratic formula. So really 5 different methods. And different methods are better probably for different types of quadratics. Here I have several up here. Notice this one has no middle term. So what's a method you could use for this one going all the way back? Yeah, just square root. So you could just take the square root of each side. And that's a method that would work. Are there other methods that would work? Could you use the quadratic formula on it? Yes, but it's like taking a mallet to something, using a little hammer to tap in the nail. I mean, you don't need to use the quadratic formula on this. I'd just move the 9 over, divide by 3, and take the square root. Something like this, x squared minus x minus 30 equals 0. Yeah, you could use the quadratic formula on it, but it's factorable. -6 and 5 would work. I mean, the only way you're going to know if it's factorable would be to find factors of -30 that add to equal -1. Well, as soon as you get to that stage, it's factorable. So I would factor to solve this one. Factor to solve that one. C there, as you're looking at it, I don't know. Do you think it's factorable? I mean, if you go and look for factors there, you could also use the discriminant to check. Watch what happens if I use b squared minus 4ac. Here's what it looks like. B squared would be 13 squared minus 4 times 6 times -17. You get, I wrote it down here, 577. The fact that I get 577 under the square root sign and that it is not a perfect square tells me I don't want to use factoring on this guy. If you don't get a perfect square under the square root sign or in the discriminant, you do not want to use factoring. What's up?
So also you could try the factors because
well, it's still possible that you multiply those 2 together and then they could add up. You could find factors of 6 times -17 that add to equal 13. It's possible. I mean, it's a not so simple quadratic. But you wouldn't find any. You won't find any that'll work here. So if you tried to factor it, you won't find factors that'll work. I think an easier way to check it is just to use the discriminant and see if you get a perfect square for this. Because if you do get a perfect square for this, that means when you take the square root, you'll get a whole number. And so you have rational solutions. If you have rational solutions, you could have factored it. Okay. But in terms of the 6 being in front of it, that has nothing to do with it. You can still use the You can still use factoring even if there's a 6 in front of the x squared. But I would use the quadratic formula on that one. What about D here? You could probably look at this. Can you think of any factors of 3 that would add to equal -5? No, the only factors of 3 are 3 and 1, and they add up to 4. So that's not going to work. If you checked with the discriminant, the b squared minus 4ac here, it'd be -5 squared minus 4 times 1 times 3. 25 minus 12 gives me 13, and that's also not a perfect square. So that tells me the quadratic formula is the way you want to approach this one. Quadratic formula. And the final one, I mean, you can make arguments for this one. It so turns out that when you plug it into b squared minus 4ac, you get a perfect square. It's a huge number. It's 3,844. I'll show you. It looks like this. -50 squared minus 4 times -16 times 21 equals, it's 3,844. And even as much of a math geek as I am, I didn't recognize that as a perfect square, but I checked it on my calculator. And the square root of 3844 ends up equaling 62. Of course, everybody knows square root of 3844, right? You guys all know that. So it is a perfect square. So this one could be factored. I don't know that I would attack it with factoring, but it can be factored. It gave me hope. The problem is you're looking for factors of -16 times 21, which add to equal -15. You could be there for a long time looking for factors that work. But it can be factored. I know that based on the discriminant. And I just had that feeling that that was the case for the previous two with quadratic formula. But the reality is, in terms of like, if this were a real life sort of mathematical modeling scenario, I would just use the formula on it, probably, rather than try to think of the factors. It'd probably be quicker to just plug in and use the calculator to evaluate it. Does that make sense? But it can be factored. No, it doesn't make sense. So the quadratic formula is really powerful, and we use it a lot. I mean, if you have handheld technology, which we always do, if you have technology, calculator in your hand, which we always do because of phones, the quadratic formula is really hard to beat. It's a very powerful formula, really easy to use as long as you have some kind of a calculator in your hand. And, now in your review, I'm going to tell you what method to use.